Okay, so we're going to analyze the decision to work using perhaps one of my personal favorite things, despite their potential methodological flaws at other levels. We're going to use my favorite thing in the world, and those are called indifference curves. I like these so much, and see, so much that I actually have a tattoo of these. I just think that they are amazing. Okay. Now, so what we're basically going to postulate. This is mathy, so pay attention and watch what it is that I'm doing here. Okay. What we're saying with indifference curves and what we're basically trying to say about people is that they want to maximize utility, right? And utility is sort of the economist word for satisfaction, happiness, joy. All things in life can be expressed as a certain quantity of what we call utils, which is a unit of utility. The whole idea basically comes from Jeremy Bentham and all kinds of cool stuff. So there's lots of cool stuff. And the basic idea is we can write your utility function, which is a function of how happy you are, as u is some function of the amount of money you have or income you earn, y, and the amount of leisure you perform. Okay, so u is, again, this is happiness is a function of how much income you have and how much free time you have, or how much leisure you consume. Right? Basically, what this is saying is that your utility is a function of how much money you have and how many hours you get to not work. Okay, so what we know is everybody would prefer not to go to work, right? You'd prefer to just have money, right? And at the same time, if you would like to get raises rather than not get raises, right? So that's all this function says, is you would like to have more money and more time off. And that seems pretty true. Okay, and what we're going to be talking about is sort of the trade-off between these things, right? So does it increase my happiness to give up an hour of labor to get an hour's increase of wages, right? If so, then give up the hour of labor, add an hour to wages, okay? And what we're going to do is we're going to build these crazy things called indifference curves. And what they look like is like this. So I'll make this axis really long. I'll make this axis a little bit longer. We can have income, y, and leisure. Okay, now it's important to note that I'm talking about leisure here. Okay, I'm not talking about work, I'm talking about leisure, right? So this is a trade-off between leisure and income. Okay, so this is how much money you earn, and this is how much time you spend not working. Okay, so 0 here. If you are here, you are working all the time that you're awake. And so what economists do is we assume that you spend 8 hours a day sleeping, and that gives you 16 hours a day in which you can either work or leisure or not work. Okay. So there's a few things that we need to go over before we go into any of this in depth. Okay, the first one is the general shape of an indifference curve. And an indifference curve looks like this. So we could call this, we'll call it I1 for indifference. Okay, so that's indifference curve 1, which is equal to some amount of utility, which we'll call U1. Okay, and we could have another indifference curve and another And let's just, for good measure, since I don't like 3, we'll add a 4th. Okay, so we have 4 indifference curves. And what these are saying, okay, what these are saying is that anywhere along this line, okay, anywhere along this line, you have the exact same amount of happiness, okay, or utility, okay. So, you know, at 16 hours a day of leisure, and, you know, this many dollars, right, you are exactly as happy as you would be if you had, you know, this many dollars and spent this much time not working. Okay, so, you know, let's say you are indifferent between having $1,000 and working for, you know, looks like 5 seconds a week, right? Or having, you know, $10,000 and working 14 hours a day, right? So you only have 2 hours, 2 hours a day off, right? So you are in this scenario completely indifferent to that. Okay. The other thing to think about is that higher indifference curves. So since both of these are good, since leisure is a good thing and income is a good thing, any movement in this direction, right, in this direction, in like the northeast direction, is good. We like that, right? That's a thumbs up. Okay, so this indifference curve, I2, right, so the relationship between I1 and I2, right, indifference curve 2 is a higher level of happiness, right, and I3 is higher than that, and I4 is higher than that, okay? So movements in this direction are good. Movements in this direction, right, and straight across this way, those are also good. Movements straight up, those are good, right? So movements up and movements right are both good, and anything in between that, so, you know, anything in this range here, any movement in this range in that direction is good. Okay, you're gaining happiness. Okay, and so another thing we can say, right? So we could assign numbers to these. So we could say this brings you, you know, 3 units of happiness. This brings you 5. This brings you 7. This brings you 9. Right? And so anywhere along this line here is the same thing as having 3 units of happiness, and anywhere along this line here is the same as having 5 units of happiness, and this is 7 units, and this is 9 units. Okay. Another way to think of these graphs, if that helps, is to think of them as sort of like a topographical map. Or a contour map. Oops. Can't spell. Sorry. Okay. So if you've ever looked at a map of like a mountain range, let's say, and it has all those lines that have elevations on it, and you can see, you know, at this point I'm 20 feet above sea level, at this point I'm 35 feet above sea level, and so on and so forth, right? If you've ever seen one of those, this is the same thing. What we're basically describing is, what these lines are basically describing is a z-axis, like an axis that comes out of the page, and it's telling you the elevation of it. So, you know, at 16 hours and, you know, $1,000, I think I said, has a elevation of 3, right? And so does, you know, 2 hours and $10,000. That also has an elevation of 3, right? It's all, think of it as a 3D map that's kind of coming off the page, right? And what we're doing is we're saying, you know, these lines are the elevation up, okay? And so logically, there's a few things that we can immediately know. You can see it through there. So let's get a new sheet. we won't waste graph paper, since evidently they sell graph paper in like ridiculously small quantities. So we're going to use just normal paper for this part, okay? So what we can immediately know is that indifference curves can never cross. Right? They can never ever cross. And let's say, this is 3 and this is 5. Okay? Because what you would have is a point here where they intersect that would be both 3 and 5. Right? It's impossible for that to be true. It can't possibly be the case that one of these points has a z-coordinate or an elevation of 3 and 5. So if you think about it, you could say, is it possible for me to hold my pen? All right, so here's my pen. Right, it is currently roughly 2 inches above the page. Right, is it possible for my pen to be 2 inches above the page and a foot above the page at the same time? Right, and the answer is, of course, no. Right, I can move it up. Right, see there. Now it's a foot above the page. Now it's 2 inches above the page. A foot, 2 inches. A foot, 2 inches. Right, I can do that, but it can't possibly be the case that right now my pen is both 2 inches above the page and a foot above the page. Same thing here. Right? It can't possibly be the case that in the same XY space, or LY space in this case, right, it cannot possibly be both 3 and 5. Okay, so indifference curves never cross, ever. Okay, they never, ever, ever cross. The other thing to keep in mind is that, yes, I only drew 4 indifference curves there, but really the whole graph is full of indifference curves, right? So there are an infinite number of indifference curves throughout this or LY space, sorry, right? So they are infinitely close, right? They fill up the whole thing, just like a mountain. At every point along the mountain has an elevation, right? So too does every point in this LY space. It has a z component or a u component that comes out, okay? And so they're complete, but they never ever cross, right? Every single space, every single combination of L and Y, including all the fractions, right, is represented by exactly one u elevation number, a u number, okay? So let's see, what else can we go through? They're going to be negatively sloped, okay? They're convex, which we'll go into a little bit. There's a few other things, okay? But what they do is they're showing sort of combinations of labor and income that you are completely 100% indifferent towards, right? You are, like, between those two baskets, or two combinations, you have exactly the same happiness, okay? So there's no difference whatsoever between them for you. Okay, so let's go through some examples here, right? So we talked about along different lines here, so we'll come back to this one. Okay, so along the same line, you have the same level of happiness. If I could move you from here to here, right, you would be happier, right? You would you'd have more leisure, but you'd have less income. But the lost income, right? So the loss in income would would give you additional leisure, which would more than make up for the lost income. Right, so this is the happiness from income lost, and this is the happiness gained from having more leisure. Okay, so you can see how much happiness you would lose. So let's do an example. Let's say I moved from here to here. So we'll say from A to B. Right, so the happiness you lose from losing income, right, would be here. Right, so in this case, you lose 2 units of happiness from A to B from lost income, right? But you get to take more time off, okay? So you gain 2 units of happiness from additional leisure. Okay, so you lose income, which, you know, is giving up happiness, but you gain leisure, which is gaining happiness. And so because this is at a point of u equals 7, and this is at a point of u equals 7, and this is at a point of u equals 5, right? We go from 7 to 5, and then 5 to 7, you're indifferent, okay? So moving from, you know, here to here would be great, right? Here, like, look at this. So what we're saying here is you have the same amount of money, but you now have more time off, right? That's a good thing. You like that. You like having more time off without losing money, okay? And at the same time, right, you would like to move from here to here, right? Because you have the same amount of time off, but you have more money, right? So from here to here is an improvement. You're happy because you work no more than you were before, but you now have more money, so you got a raise. That's a good thing, okay? So we know certain things. We can know certain things by understanding the indifference curves and what they look like, okay? So let's see. We can think about the shape of the indifference curves, and I am going to do it on the back of this sheet, so you'll be fine. Okay, so the shape of the indifference curves can tell us things as well. So let's draw 2 different indifference curves that look different from each other in one respect. Okay, so we'll draw one that looks like this and one that looks like this. Let's call it UA, and we'll call it UB. Okay? So here's a question that I could ask you. Which one of these people, so these are 2 different people, right? So person B, oops, and person A, right? Which person prefers or has a low value of, let's see, of working, right? So who values working the least, okay? And which person values leisure the most, right? And so let's think about this, right? So who values leisure the most? So pause the video and see if you can answer the question based on the indifference curve. Okay, so have you given it a shot? Hopefully you did, right? And so we can say, look, let's think about it. So let's say this person goes from here to here, right? Okay, so they give up. So in order to induce them to give up a little bit of leisure, you have to give them a lot of money, right? So in order to get this person to do just a little bit more work, because remember, this is hours of leisure. So this moving this way is doing more work, right? So to the left is more work, to the right is more leisure, okay? So getting them to do just a little bit more work takes a lot of money, right? And so this person must value leisure very highly, okay? And this person, right, in order, if you give them just a little bit of money, okay, so we come straight over, right? If you give them just a little bit of money, so here, they'll give you a whole lot of their time, right? So just a little bit of money yields a bunch of time, Okay, and so this person must value money or income very highly. Right? So what could we infer about these people? Well, this person, right, they probably have lots of things they could do that are fun, right? So maybe they own like a jet ski, and they live in Florida, let's say. So if you own a jet ski and you live in Florida and you can ride the jet ski around for free, let's say, or you don't have to pay for gas, or it's cheap enough, right? To get you to come into work means you got to give up the jet ski, right? Or you got to give up surfing, or sitting on the beach, or doing whatever it is that people in Florida do for fun. Right? Maybe they go golfing, right? So all the things that people in Florida do that are fun, that are more fun than some of the things that you and I get to do, right? You have to convince them to give that up. And that might be really valuable to them. They might be like, man, I just love waking up in the morning and riding my jet ski. And so in order to get me to give up riding my jet ski for some amount of time, you've got to induce me with a lot of money, right? These people, well, maybe they don't have as many fun options, right? Maybe their television doesn't work, their Xbox is broken or whatever, right? And so the opportunity cost of their leisure is evidently very low, right? What they can do with their time is limited. They're like, yeah, I got nothing, right? They got nothing to do with their free time, and so they're like, yeah, screw it, I might as well earn some money. And so you can pay them a little bit, and they're like, yeah, I mean, I'm not doing anything, so might as well work for you. So they just work a whole bunch, right? Or this could also be someone who just loves their job, right? So I would submit that this is sort of like me, because you can pay me a little bit more and I will do a lot more things that count as work, right? Just it's the case that they're fun to me. So you pay me a little bit more, I will give up a whole bunch of my time, right? But I love the time that I give up, so it's an interesting puzzle, right? So anyway, we can know a lot about people based on knowing what the shapes of their indifference curves are, right? And that's kind of cool. So you can start thinking about individual people as sets of indifference curves and say, oh, well, what the hell are they going to look like, right? And you can figure these things out, and it becomes, really, really cool. Okay. Now, what these allow us to do, which is the crazy thing, is analyze a whole bunch of things. And so let's do an example. So what we can do is we can draw these axes, and I'm going to draw them big, mostly because I don't want to run out of space. So we have income and leisure. Okay. Now we know that there are 24 hours in the day. Okay, so there's 24 hours in the day. Economists typically assume that you have to, so let's call this 24. Okay. Economists typically assume that you sleep 8 hours a night, and so that means you have 16 hours, right, with which you can allocate between either leisure or work. Okay, now realistically, yes, you can go into the 17th hour. You guys have pulled all-nighters, I'm sure. I don't recommend it ever, but you do what you feel is best. But basically, under normal circumstances, which is what we're concerned with, people have 16 hours in the day with which to play with. Okay, so I remember this is hours of leisure, and moving this way means you're working more. Okay, so you work more going this way. Okay, now, how can we illustrate the trade-off that people face? Well, what we're concerned with is a budget constraint. Okay, and so let's say that you can work for $10 an hour, so we'll keep it simple, $10 an hour, and you can work up to 16 hours a day. Okay, so if you work all 16 hours of the day, you'll have $160, right? And so, so no mysteries there, right? And so if you work all the time, you will have $160, but 0 hours of free time, okay? Or if you work 0 time of your 16 hours, you'll have 0 income, but you'll have 16 hours of free time. Okay, and so what we can do is I'm going to use a straight line to draw this, is we can say that your budget constraint lies along this line. Okay, and so now that we have sort of this straight line, which is the trade-off, let me see if I can make it thicker. Hang on. I want you guys to be able to see this easily. Whoops. Shoot. There we go. Okay, that's thick enough. Okay, so what we have is a budget constraint detailing the trade-off between hours of free time and dollars. Okay, so if you want to maximize something, you want to be along this line. So let's just throw some indifference curves on this graph. So let's put one here. All right, so I'm just making up indifference curves. I'm going to call it U1. Okay, let's put one. We can cover up my mistake with an indifference curve. There's U2. Okay, so let's see if I can do this very carefully. Ooh. Okay, and for good measure, we'll have U4. Okay, so I've got 4 indifference curves. Okay, and so remember, I face a trade-off between hours of leisure and dollars, and I can, in principle, well, I guess I can't be below this line in this case, so I have to be along this line. And so let's think about it. I could be here, and let's assign some numbers. So we'll say 3, 5, 7, 9. Okay. Okay, so I can be here, which gives me 3 utils, okay? Or I can be here, right, which will give me 5 utils. And so what I want to do is be on the indifference curve that is tangential. So you can maximize happiness, or utils, by being on the indifference curve where u sub n, so whatever the number is tangential, which means it touches once, to the budget constraint. Okay, so at this point here, you have maximized the amount of happiness that you can possibly get. All right, given your wage rate, given that you're only going to work 16 hours in the week, okay, you have maximized, or 16 hours in the day, right? You have maximized the absolute most, you've maximized the happiness that you can possibly get, okay? You cannot be any happier than right here. Now, if you could, right, if you could, you would love to get up to this indifference curve, right? You would love to be up here, okay? But that point lies beyond your capabilities. So this constraint here is sort of the hard constraint. This is like, yes, I would love to have $1 million, but I can't, right? If that kind of makes sense. I'd love to be a millionaire, but I'm not, so I have to do with what I can, okay? So at that point, you have maximized your happiness, okay? Now, let's consider the case of getting a raise. Okay, so if you get a raise, okay, so we'll do this again. I'm going to be less careful this time around. 16, and let's say 160. Okay, well, actually that's a lie. I'm too perfectionist with this stuff to be less careful. All right, so here we are. Okay, there's our budget constraint. And let's say that we get a raise. Okay, so now instead of making $10 an hour, let's say we're making $20 an hour. And unfortunately, I'm going to have to scale this. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if I'm getting paid $20 an hour, I still can only work 16 hours in the day. So the maximum I can get is $320. Right? And this is, of course, 160. So this is $20 per hour, and this is $10 per hour. Okay, I'll write bigger. Sorry, I don't know if you can see, you can read these small numbers, but anyway, they're 320 and 160. But here's the thing: it's not the case that I can have more than 16 hours of work or leisure anymore, right? Just because I got a raise doesn't mean that I can now work more than 16 hours or work less than 16 or have more than 16 hours of leisure. Okay, and so what happens when you get a raise is this budget constraint will rotate up, right? It just rotates up like that, but it's still fixed to this point. So it becomes, if I can do this real quick, it becomes this. Oops. Paper's wearing out. It's not holding up as well. Okay, so your budget constraint actually rotates up until it gets to your new maximum income, where if you were working all day, if you worked 16 hours a day, you'd have $320, right? So if you get a raise, your budget constraint rotates up. If you lose your job and have to take a lower paying job, it would rotate down. Okay, so promotions and such rotate up, demotions or firings rotate down. Okay, all right, so we've kind of got an understanding of that, right? And let's see what happens when let's do another example. So let's say that I have Y and L, and we're at 16, okay, and 160 again. And let's say that I got I found $40. Okay, so I find $40, or someone gives me $40, and now I have more. Okay, so we're gonna just do this quick because I actually have to get out of here soon. Close enough. Okay, so we have our budget constraint, and if we were to find $40, we would say, oh, now I have $20, so I've moved up 2 squares. And so what happens here, since our wage rate has not changed, right, we would just move this line straight up. Okay, so this is one of the few times in economics where lines go up. Okay, so we move it up, and I will be persnickety with this one, so I will draw it using my handy dandy tool. Okay. There. Right, and so what we would see is the curve shift straight up by the amount of by the amount that our money increased due to non-labor. So shift up due to non-labor increase, non-labor income. Okay, so we just shift it up by the amount, and here, it of course rotates. Okay, and so the cool thing that we can also know, is that the slope of the budget constraint is equal to the wage rate. All right, it's equal to the hourly wage that you are earning. Okay, so the slope of this line is equal to the wage that you are being paid, right? And its elevation from up here is equal to your non-labor income. Okay, so let's say you win the lottery, right? It goes up by 300 million. Okay, and then it slopes at 10, right, or -10 rather. Okay, and so because you make $10 an hour or whatever you're making. Okay, and so we can do a lot with these indifference curves. Okay, and we'll do some more in coming up.